Beta-lactam antibiotics are those antibiotics which contains a beta-lactam ring in their structure. This is the figure of beta-lactam ring. For example, penicillin, cephalosporin, monobactam, and carbapenems. Penicillin have the beta-lactam ring with thiazolidine ring. Similarly, cephalosporin have the beta-lactam ring with dihydrothiazine ring. Beta-lactam ring is 4-membered ring and thiazolidine ring is 5-membered ring. Similarly, here cephalosporin beta-lactam ring is 4-membered and dihydrothiazine ring is 6-membered. The difference between penicillin and cephalosporin is here the thiazolidine ring have 5-membered ring with beta-lactam ring, and the cephalosporin has also beta-lactam ring, but here 6-membered ring dihydrothiazine ring is present. So these all beta-lactam antibiotics have similar structure is beta-lactam ring. Beta-lactam ring is compulsory, which is responsible for the bactericidal effect. Now, all beta-lactam antibiotics are generally bactericidal in nature, means not inhibit the growth of bacteria. Bactericidal means kill the bacteria by inhibiting cell wall synthesis in bacteria. How it inhibit the cell wall synthesis? By inhibiting transpeptidase and carboxypeptidase enzyme, which is responsible for cross-linking between peptidoglycan layer. If cross-linking not occur, then cell wall deficient bacteria are formed, and these bacteria are die due to imbalance in water. Now, briefly discuss about penicillins. Penicillins are obtained from natural source. That is, first time it is obtained from Penicillium notatum. Who discovered the penicillin? Penicillin is discovered by the Sir Alexander Fleming. Nowadays, commercially, penicillin is obtained from Penicillium chrysogenum. That is also a fungus. Penicillin was first antibiotic which is developed and used clinically in 1941. Penicillin was discovered by Sir Alexander Fleming. Penicillin is generally two rings. Penicillin contains two rings. One is beta-lactam ring and another is thiazolidine ring. Here it is the figure of penicillin. Its IUPAC name is bicyclo-3,2,0-heptane because here 7 carbons are present, so its name is bicyclo-3,2,0-heptane. How it is named? IUPAC name is IUPAC name is given in this figure. Let's example. Here a structure is given. Here two cycle is here the one cycle is 3 carbons and another cycle is 2 carbon. Middle have 1 carbon. So in this structure we can name as 2 cycle indicates bicyclo. 3 first count the large cycle. Here the large cycle has the 3 carbon, small cycle has 2 carbon. So The large cycle is 3, then second small cycle 2 cycle, 2 carbon, then the middle have 1 carbon, so 1. Bicyclo 3 to 1 octane. Then comes into the classification of penicillin. Penicillin is classified into following categories. Naturally, it is named as naturally the penicillin is named as penicillin G. Naturally obtained penicillin is penicillin G, that is also called as benzyl penicillin. These penicillins have the narrow spectrum of activity. Spectrum activity is narrow, means effective against only one type of bacterium, and also degraded in acidic pH. So two demerits in the natural penicillin have the two demerits. One is narrow spectrum and another is degraded in acidic pH. So researchers then again develop a semi-synthetic penicillin, which is penicillin V, or also called as phenoxymethyl penicillin. These penicillins are resistant to acidic medium, or acid resistance penicillin. It is also called as acid resistance penicillin. But here is also a demerit, that is a narrow spectrum of activity is narrow. So again, researchers or scientists develop another type of penicillin, that is synthetic penicillins. These penicillins are acid resistance and have broad spectrum of activity. So these are also categorized as extended spectrum antibiotics. Here the drugs are comes aminopenicillins. Aminopenicillin, under the aminopenicillins, ampicillin and amoxicillins are the drugs. Next category is carboxypenicillins. Under the carboxypenicillin class, carbenicillin and ticarcillin are the drugs. Then another class is uridopenicillins. Under the uridopenicillin, drugs are mesalocillin, azolocillin and piperacillin. After use of these drugs, then bacteria again develop resistance against these penicillins. Gram-positive bacteria produce penicillinase enzyme. Gram-positive bacteria as a resistance develop penicillinase enzyme, which open the beta-lactam ring, which is responsible for the antibacterial property, so that our drug is inactivated in the bacteria. So bacteria are not killed. Similarly, gram-negative bacteria produces beta-lactamase enzyme, which open the beta-lactam ring, so the drug is get inactivated. So again, uh, scientists develop more advanced medicines or drugs, that is they block the penicillinase enzyme, so target the penicillinase enzyme. Now the researchers target penicillinase enzyme and beta lactamase enzyme. They develop penicillinase inhibitor drugs, that is oxacillin, cloxacillin, dicloxacillin and moxacillin, and similarly develop beta lactamase enzyme inhibitor, that is clavulanic acid, salvectam and tozavectam. These drugs are given with the combination of synthetic penicillins so that bacteria are completely killed. So that the bacteria are completely killed. Now comes to the mechanism action of penicillins. Penicillin, when we eat penicillins, penicillin go and bind to the specific receptors present on the bacterial cell membrane, that is penicillin binding protein. Bind to the penicillin binding protein. Penicillins are comes and bind to the penicillin binding protein and inhibit transpeptidase and carboxypeptidase enzymes, which are responsible for cross-linking of peptidoglycan chain. So cross-linking of cell wall does not take place. As a result, cell wall deficient bacteria are formed and die due to imbalance of water. This is the mechanism of action of penicillins. How it is act. Now we can see the adverse effects of penicillin. The major adverse effect of penicillin is Jerick-Hexamer reaction. When penicillin is injected into the syphilis patient, they may develop Jerick-Hexamer reactions, which can be treated with the aspirin and corticosteroids. Another adverse effect is anaphylactic reactions. Another adverse effect is ampicillins can cause diarrhea. Similarly, now comes to the uses of penicillin. Penicillin G. Penicillin G is the drug of choice for neurosyphilis. Syphilis is a type of sexual transmitted disease which is caused due to Treponema pallidum. Treponema pallidum is the causative agent for the syphilis, and the penicillin G, natural penicillin, is the drug of choice for neurosyphilis. Similarly, another uses are Bacillus, Leptospora, actinomycins, Streptococcus, tetanus. Also, penicillin treat these diseases, these agents. So simply, uh, uses of penicillin can be memorized by a trick, that is blast. 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 Trick is blast. To use to memorize the uses of penicillin. B stands for Bacillus. L stands for Leptospora. A stands for Actinomyces. S stands for Streptococcus. T stands for tetanus or Treponema pallidum, syphilis. Now we can see the combination drugs with penicillins. Amoxicillin plus clavulanic acid. Amoxicillin plus clavulanic acid. Amoxiclav. Amoxiclav is widely used when amoxiclav is widely used, and amoxiclav is the drug of choice for gonorrhea. Gonorrhea is one type of sexual transmitted disease. In gonorrhea, the drug of choice is amoxiclav. Amoxiclav is widely used. When you come to hospitals or you come to the DDCs, drug distribution centers, you can observe how amoxiclav is widely used. Then another combinations are there: salvectin with ampicillin, tazobactam with piperacillins, aminoglycoside with penicillins, When aminoglycoside given with penicillin, it produces synergetic effects.